The fifth principle of knowledge-based AI, as we have discussed it in CS 7637, is that AI agents use heuristics to find solutions that are good enough, though not necessarily optimal. Some schools of AI put a lot of emphasis on finding the optimal solution to every problem. In knowledge-based AI, we consider agents that find solutions that are good enough. Herbert Simon called this satisficing. The reason for finding solutions that are only good enough is because of a trade-off between computational efficiency on one hand and optimality of solutions on the other. We can find optimal solutions, but that comes at the cost of computational efficiency. Recall one of the conundrums of AI. AI agents have only limited resources, bounded rationality, limited processing power, limited memory size. Yet, most interesting AI problems are computationally intractable. How can we get AI agents to solve intractable problems with limited rationality and yet give near real-time performance? We can get AI agents to do that if we focus on finding solutions that are good enough, though not necessarily optimal. Most of the time, you and I as human agents do not find optimal solutions. The plan you may have to make dinner for yourself tonight is not necessarily optimal. It's just good enough. The plan that you have to go from your house to your office is not necessarily optimal. It's just good enough. The plan that you have to walk from your car to your office is not necessarily optimal. It's just good enough. Further, AI agents use heuristics to find solutions that are good enough. They do not do an exhaustive search, even though exhaustive search might yield more optimal solutions, because exhaustive search is computationally costly. We came across this notion of heuristic search several times in this course. One place where we discussed this in some detail was in incremental concept learning. Given a current concept definition and a negative example, we arrived at a new concept definition by using heuristics like the required link heuristic. The required link heuristic adds the must clause to the support link between these two bricks. Mean sense analysis was a heuristic method. It said that, given the current position and the goal position, find the differences and then select an operator that will reduce the difference. Because mean sense analysis was a heuristic method, sometimes it ran into problems and did not provide guarantees of optimality. But when it worked, it was very efficient. Another place where we explicitly made use of heuristics was in the generate and test method. Here we had a heuristic which said, do not generate a state that duplicates a previously generated state, which made the method more efficient. Thus, the focus of knowledge-based AI agents is on near real-time performance and addressing computationally intractable problems with bounded resources, and yet being able to solve a very large class of problems in robust intelligence and flexible intelligence. And that happens not by finding optimal solutions to a narrow class of problems, but by using heuristics to find solutions that are good enough to very large classes of problems. This principle comes very much from theories of human cognition. As I mentioned earlier, humans do not normally find optimal solutions for every problem they face. However, we do manage to find solutions that are good enough, and we do so in near real time, and that's where the power lies.